That
Okay, guys, welcome to week 2 of Pandas. You guys have survived week 1. Congratulations. Um, so today I'm going to be mainly talking about data extraction and filtering. Um, so of course, one of the biggest questions, I guess, when you have a data frame is how do you extract the data out of it, right? And so that's what we'll be looking at first. So quick review from last time. We defined what a data frame is, right? Which is the most important data type in Pandas, where it's made out of columns and where each column is just a series, right? And there's, of course, a row and a column and an index, right? Why is that weird? Okay. So then, as mentioned before, the key point last time was that a table, a data frame is just a bunch of columns combined, right? With the exact same index. And this will be important today as well, this concept that a column is just a series. So how do we actually extract information? Okay, so the most basic extraction is this dot index. Okay, you just do this. The table we're looking at is SAT, which is the average SAT score by state. And this is the data set I'll be using like today for literally all of our examples. Um, so if I type in SAT.index, I will just get an index object. You don't really need to know what that is. You just need to know that most of the time it's like 0 to however many rows there are, right? So in this case, there's 51 states. Well, okay, wait, what? Wait, there's 50 states and then a Dominican Republic, I think, for 51 rows, right? I'm not sure if you guys are familiar with the ranges in Python, but it's like pretty much that, right? So it's just 0 to 51. Um, a quick note is that indexes do not have to be unique. Which is like kind of weird, but you'll see like more examples later when we talk about group by. Also, indexes do not have to be numeric. And again, you'll see another more examples of this when we do group bys, which is next week. There's also a set index, right? So if I want to change my index, I can just change it to a column, right? And the basic syntax is the data frame's name dot set underscore index and then the column name. So like I said, it just sets it next to another column. And again, this will be more apparent when we talk about group by. So in the SAT example, if I do sat.setIndexState, I set the index to state, right? So now each column is defined by the state rather than some arbitrary 0 to 51, right? A data frame also has a reset index. So it literally just puts it back into the 0 to 51. And again, it's not that clear why this is useful, but it will become very useful when we do group bys. There's also a very did I skip a slide? Yeah, okay. I don't know why it does that. Okay, anyway. So another basic extraction is dot columns and dot shape. So data frames dot columns, notice there's no parentheses, right? It's not a function call, it's like an attribute if you guys are well versed in Python. But what this does is that it just outputs the names of the columns as another again an index object. But for this you don't really care what index object is. Just think of it as like a list of column names. So if I do sat.columns, I return this index object with just the column names, right? So if I'm looking at some unknown data and I want to know which columns it has, I just output the data frame's name dot columns, right? There's also a very useful feature called data frames dot shape, which what this does is that it just returns the number of rows and the number of columns, right? So in this SAT example, right, if I call SAT.shape, there's 51 rows as I talked about before, and there's 6 columns, right? 1, 2, 3, 4, 5, 6. Notice the index does not count as a column. Another quick thing, these are just like the most basic extractions, right? There's also a dot head. So I want the dot head will just basically you input an integer and it will basically just tell you how like the first n rows of that table. Right? Just output the first n rows of that table. So in this case, std.head3 will output the first 3 rows. Right? And then there's also dot tail, which are the last 3 rows. Right? Again, I'm going a little quick, but these are just like a little like small things that I guess we need to define. So why did it okay. And so now we get into like the more sophisticated extraction techniques, right? So the first one is dataframe.loc, which takes in row labels and column labels. So dataframe.loc, and I will go into details like specific, like very specifically after this general slide. So it allows us to access specific rows and columns we wish to extract. And it's by labels, right? Again, you'll see what I mean by that very soon. So what these row labels and columns could be is a list, a slice, and a singular value. So df.loc in a list, right? So I can pass in 2 lists to extract, right? So in this case, arguments to .loc will just be a list of rows and a list of columns. Now, intuitively, that just returns like the lists and the columns that you've selected, right? So in this example, sat.loc, I put the square brackets, these square brackets, then I put a list of rows. In this case, it's 0, 3, 5, 7. And then I put a list of columns, right? These are just Python lists. These are not like fancy series or anything, right? And so what this will output is the lists, I mean the rows I selected and the columns I've selected, right? So it works exactly as intended, right? So I have the 0, 3, 5, 7, and then the state and the math column. Notice that these are strings. These are column names. This will become relevant soon, right? So this is the very first, I guess, sophisticated extraction, right? You can imagine like the use cases for this. I just want this specific row. I want these specific columns, right? There's also a slice. Now, a slice is, if you're familiar with Python, it'll be like a lot more easy to comprehend. If you're not familiar with Python, I'll give like a little insight on what it does, right? So a slice, okay, so first of all, I'll explain what slice is. So a slice of some array, so some array, this is the Python list, and I slice it 1, 4. This was the slice the array, giving me the elements that were originally in 1, 2, and 3. So similarly, we can treat columns as lists, right? Remember the dot column, we can treat that as a list and slice into them, right? So a slice in this case, this is okay. This is kind of ridiculous, but it's the only so slices are normally exclusive, right? But in this case, it's the only inclusive slice that exists in literally all of coding. I don't know why it does that, but it's just that. Okay, so again, I'll go into like an example in the next slide. So df.loc will again take in a list of rows, right? And then column A slice column Z, right? So, oh, you can also just put in 1 colon, just that's why I want all the columns, right? Okay, this is also rarely used, the slicing idea. So an example is that I want the rows 0, 3, 5, 7, and I want the slice state to writing. Now, what that means is that I want all the columns from starting from state all the way to writing, right? Notice that this slice includes the last element, this writing. It includes both endpoints. In every other slice, in every other coding language, even in Python, even in other pandas functions, they do not include this last endpoint. This is literally the only function that includes the endpoint. And I think it's because we're like slicing strings, right? Like these are column names as opposed to like column indexes. So again, this should be pretty intuitive, right? So I just pass in a list of rows and then a slice of columns. That will give me like, so this is so that I don't have to put like state, participant rate, critical reading, math, writing all into this like long chain, into like a very long command. And then lastly, what I can put into loc is a single value. So again, let's say I want to select the rows 0, 3, 5, 7, but I only want to select one column. What this will output is a series with 0, 3, 5, 7 as the indexes, right? And then it'll give me the value of state at those three indexes, right? Again, this is like works as intended, right? Like I mentioned, a column is just a series. So if I select a very specific column, it should return a series, right? And then I'm looking at this SAT still, right? And if I only select the first row, but I select a slice of columns, right? This will give like a little bit of weird behavior, right? Where now my columns become the index, right? This I've literally never seen this like weird thing used in practice. I've never seen like somebody change the columns into row indexes, because to be honest, it doesn't really make any practical sense. It's just like a fancy thing you can do. Um, and yeah, so like the state is North Dakota, the participant rate is 2.3. So like you've kind of like turned the table on its head for some fun reason. And then lastly, which is a lot more relevant, is you put two singular values. So I want only the first row and I only want the state column. That will just give me 0 and then the first state, right? Which is a string. This returns a string, North Dakota. So if I ever asked you, um, which state got the highest uh SAT score, right? I'd sort by SAT score, then I'll dot loc 0, then the state column, right? It gives me the very first value. There's a very similar command called iloc, which is literally the exact same thing as loc, except instead of labels, we use numbers. So instead of using row integers, well, in the previous case, our rows were integers, right? But we use column integers instead. So remember how when I said you can think of columns as just like a list, right? So this would be like a lot more similar to Python, where I'll give examples of that, where if I put 0, then I would get the first element of the columns list, right? Which in our case is state. So again, the arguments that can be passed into iloc are the exact same thing that can be passed into loc. Pass in a list, a slice, and a singular value. Since this is like literally almost the same thing, I'll just do like a quick examples, right? So this is as I mentioned before. So instead of putting specific column names, I just put it as the index of the so-called column list, right? So if we look at where's my all right, I'll quickly load the table really quick. So if I want, this is the 0th, the 2nd, and the 5th column, right? So the 0th is state, 0, 1, 2. The 2nd is critical reading, and the 5th is combined, right? So in this case, we've selected the state column, the critical reading column, and the combined column. Again, I can put in a slice. This slice, however, does not include the last element. Okay? It's really stupid. I don't know why they designed it like this, but literally log is the only one where the slice contains the last element. Okay? But this one, it works as a normal Python slice and does not include the 5th. Right? So the 5th that we talked about before was combined. Notice that, okay, combined is not outputted here. I noticed that. Right? So again, I've selected rows 0, 3, 5, 7, and I've sliced the columns 0 through 5. So I've gotten 0, 1, 2, 3, 4. Basically, is what the slice does. So, okay, yeah. Another quick thing with iloc, right? So instead of putting the word state, I just put the number 0, which I guess is faster, right? And I'll put the exact same thing as before. Exact same thing with this, like the fancy, like turning of the table nonsense. Actually, like I've literally never seen this used, like I said before, where I take the first row and then I take the 0th, first, and 4th column. So the 0th column is state, the first column is participation rate, and the 4th column is writing. Right, so you see the state, the participation rate, and then writing. Right, and you see their values over here. And then again, probably the most important one on the slide is if you put 2 zeros, you get the 0th row and the 0th column and that value. So you literally get 0.00, which in our table's case is North Dakota, right? 0, 0, North Dakota. It returns as a string. Now, if you guys are not confused yet, be prepared to be extremely confused, okay? Because we data scientists and computer scientists are very lazy. So we always look for a very shorthand ways to write things. So there's these square brackets, which I gave like a little sneak peek last week, where I can extract with square brackets. Now, these square brackets can only take one element. So instead of 2 elements, which are like the row labels and the column labels, it can either take a slice of row numbers, a list of column labels, or a single column label. Right? So like, what does that even mean? Right? Because it basically, like, you put in like a different object, right? It'll output a different thing. That's basically what it is. So that's why it's called context dependent extraction. Depending on what I put in the square brackets, it will be a completely different output. So in this case, if I put a slice, in here, it will automatically assume I'm talking about rows, right? And that's just a shorthand, okay? There's no like reason for that. We just wanted a very lazy way to extract rows, right? So in this example, the extraction and a slice of row numbers. Notice I don't have to put like the .loc. Notice I don't have to put like the very lengthy list, right? There's like very, I guess, verbose line of code to like do things, right? So instead, if I just put a slice and only a slice, anything else will have a completely different output. If I put in a slice, I can extract the rows, right? So in this case, if I want rows 4 through 16, I can just put the table, then these shorthand brackets, then 4 slice 17, right? Notice this also does not include the last element, unlike loc, right? So in our SAT example, if I do SAT for 17, I'll get rows 4 through 16, right? Notice this is a lot more compact, a lot prettier, a lot more concise. If I wanted to use .loc, I could. I would just have to sat.loc. Then I would have to specify, like write a list 4 through all the way to 17. Then I'd have a comment, put a comma, then I put these list of columns, right? Now, if I do not put a slice, however, as mentioned before, the behavior completely changes. And that's what's like really confusing about these like square brackets. So instead, if I put a list in, it will immediately assume I'm thinking about columns. Okay. And again, there's no reason for this. We are just lazy people, and this is just a shorthand we invented. Right. So instead, if I do not put a slice and I put a list, it will immediately assume I'm trying to extract out columns. Right. So it's basically saying every column in that list, I just output it and put it into a data frame. Right. So if I want only the state column, the math column, and the combined score column, I just put this very nice short annotation, put these square brackets, then put a list of all the column names I want to select. Again, this works as intended, right? It's very simple. And again, notice how nice and concise this notation is. If I wanted to use iloc or loc, I'd have to specify SAT, then for the bracket, then I put colon for I want all the rows, then I'd have to put a comma, then the list, right? And it's important to know all this does is select the columns for us, right? And okay, this is also very commonly used. In real life data, your data is gonna have like 200 columns, and you only want to look at like 3 of them. Okay. So you just immediately run this, take out the 3 that you want, and just only work with the 3 that you want, right? Now, the lastly, and this is the most commonly used version of this bracket, which I showed you guys a little bit last week of these square brackets, is that if I put one string, so I do not put a list of columns, I put in one singular value. I do not put a slice, I put one singular value, right? Again, a slice and one singular value are completely different things, and it'll output completely different things, right? So in this case, if I put one singular value, which is a column name, it'll output that column name as a series. And this ties back to what I was talking about before, right? A column is just a series, right? So in this case, if I just want the state column, right, I can just call this very nice compact notation, and it'll output a series of the state, right? And it's sort of unclear on why this is useful, but I hope it'll become apparent by when we talk about filtering, right? Again, this is very, very commonly used, right? This is very important. This idea of selecting one column out. So, okay, I guess I'll stop here and do a quick demo on what we look at so far, which is the loc, the iloc, and the brackets, right? So if I do this import.pandas.pd, this is how you just import pandas in. If you put this is like a nickname. So this is basically saying, so instead of calling like pandas like this, every time I want to call a pandas function, I can just do PD. Okay, so it's like fast. This is just data I found online. This is the SAT scores, right? So first of all, remember the dot head. I only want to look at the first 15 entries because I don't want to output like all 51 rows, right? So I can just call dot head 15, first 15 entries. You see the North Dakota we're talking about. So the SAT dot index, right? Just take out the index column, which will be a range. This range index, if you're familiar with a Python range, it's exactly the same thing. This is just 0, stop at 51, and then step size 1, right? So it's 0, 1, 2, 3, 4, all the way to 51. Or 50, right? Because it stops at the last one. And then I can also do a set index, right? So I don't want these 0 to 51 anymore. I want my state to be the index. I can use a set index, state, and then I want only the first 15 rows. So I don't want to output the whole table again, right? Why did I output nothing? Okay. Okay, there we go. So now notice our 0 through 51 column is gone, and now we have states. So now we index by states. So now if I want to do like an iloc or a loc, instead of putting row numbers, remember, instead of putting row numbers, I'd put state values, right? State strings when selecting. And then there's a very important function, reset index, right? Which just basically says, okay, I no longer want the state index. I just want to go back to 0 to 51. This was also part of our initial attributes, right? SAT.columns. I just want the column names, right? This will just output the column names in this index object, which again you don't have to worry about. Just assume it's like a list of columns, right? So we have state, participation, critical reading, math, writing combined. Works as intended, right? And lastly, we have the SAT.shape, which just outputs the dimensions of the table. As I've already mentioned quite a bit, head it's just the first three rows, right? So if we see here the first three rows, tail is just the last three rows. This is tail is mainly used when you either want to like polarizing data, so you can get head and tail at the same time, or your table is sorted in the wrong order for some reason, so you want to get at the end. And this is and so I guess we'll look at the examples of lock, right? So this is the case where both entries are lists, right? So this is just saying I want row 0, row 3, row 5, and row 7. And then this is basically saying I want columns, state, and math. And if we output this, that's exactly what we get, right? Row 0, 3, 5, 7, and state and math. If I want the columns from state all the way to writing, I want all of these. I make this slice, which again, this is the only case where the last element is included in the slice. Okay, and I still want the exact same rows. You'll see it works as intended, right? I have rows 0, 3, 5, 7, and then I have this slice I've created. So this just allows us to not basically put in like this is a very lengthy list, right? Where I have to like do all this stuff. It's just a very nice, convenient shorthand, which again, the brackets is actually more like the singular brackets is more convenient, right? But so in the df.loc, if I only put in a singular value, the state, I only want the state column, right? It'll output a series with only these 4 rows. And again, this works as intended, right? The state value, what's the state value at row 0? North Dakota, South Dakota, Michigan, Missouri. Right, works as intended. And then this 0, it's just basically saying I only want row 0, but now I want a slice of columns. This is the table flipping thing I was talking about, which again is basically useless, but it's cool that we can do it, I guess. And then lastly, the most important one is I want to select the first element of the column 0 or the row 0, and column 0, right? And that's just North Dakota. If we look at our original table, row 0, column 0, North Dakota. If I, for example, change this to 10, I want the 10th best SAT score by state for some reason, then I get Kentucky, Kentucky number 10, right? Next, we have iloc. Again, I'll quickly run through iloc. It's basically the exact same thing as loc, except you replace the column names with numbers. So I want index 0 to 5. Index 0 is state. Index 2 is critical reading. 5 is combined. Right. So if I output this, I have rows 0, 3, 5, 7, state, critical reading, and combined. Right, works as intended. I can also slice the columns. One column 0 to 4. Again, this does not include the last one, unlike the loc, which is again very stupid, but whatever. iloc, basically exact same thing as before, right? I want only the 0th row, but I want these 3 columns. I'll return this fancy table flipping, right? And then I want the 0th column and the 0th row, which again, the 0th column is just state, right? North Dakota. If I change this to 10, this should give me Kentucky again, right? Lastly is the shorthand notation, where if I want rows, I'd put in a slice, right? Where slice is just an object with this colon, right? So I want rows 4 through 17, which doesn't include 17, right? Because slices don't include the last index. As you see, it's worse than 10. I have all of my columns, and I have 4 through 16. All right. A very nice compact notation. If I put in a list of column names, I'll put a table with only those column names, with all the rows. Right. So I have all 51. rows, but I only have 3 columns. Right? Again, very convenient, very shorthanded, very nice. And then lastly, I only want the state column. I'll put this, and it'll give me a series of all the states. So that's like the very basics of extraction. And if you really think about it, this is like all we need to extract data, right? Later on, we're going to do like a very fancy manipulation of the data that will allow us to, I guess, extract more interesting information. But this is like all we need basically, right? We know how to get specific rows. We know how to get specific columns. And a table is just rows and columns, right? So now we come into, I guess arguably a more interesting topic is how do we filter data, right? Let's say I only want SAT scores above 1540 because I'm looking at only like prodigy states or something, right? Then how would I get that? Now, in order to, I guess, first introduce filtering, I need to introduce what is called a Boolean array. Now, what is the Boolean array? As the name suggests, it's literally just a list of trues and falses. All right. True, false. You see this example, true, false, true. Well, dynamic example, right? Sometimes there's also 1 and 0s. I'm not sure if this is going to be required of you guys, but just know that sometimes 1 equals true and 0 equals false. I think if you directly just put in an array, it will not work. But there's like certain functions that convert it into like this form. So just be like mindful of this form, right? So the core idea of the Boolean array and why it's so good for filtering is that if I put a Boolean array into these brackets, okay, I lied to you guys. Remember, I told you guys you can put 3 things. No, I can also put a Boolean array and it'll do a completely different action, right? This will keep only the rows where the index in the Boolean is true. And I'll give a like way more detailed example of what I mean by this. And just know what this implies is that the number of rows of the data frame has to equal the length of the Boolean array. As in every index has to have a Boolean. So here's my cool example, right? So if I put SAT, I've got this 2-column list, like the SAT, but like with everything trimmed off, right? So I put the data frame, and then I put a Boolean array of trues and falses. Notice that there's 10 entries over here, and there's 10 values, 10 trues and falses, right? So I select where all the trues are, and I find their index in the array. So 0th index, true, so I want to keep that one, right? So that's North Dakota. I put this in, I go into the table, it's here, okay? This next one is false, Illinois. I do not want this table anymore, right? I've like created these circles for like which ones coordinate to which ones, right? So I no longer want this Illinois. And then so my final table will not have Illinois, right? This one, true. This refers to Iowa. I want to keep Iowa, right? So basically, I look through this array. If at that index it is true, then I go to the table and I look for that index and I keep it. If it is false, I throw it away. Now, it's not so obvious why this is useful yet, right? Because imagine if I have a table of like 5,000 columns. I do not want to go through every row and be like, I want this one, I don't want this one, I want this one, I don't want this one, and create my 5,000 linked Boolean array just to filter, right? Now, okay, yeah, I can also do this with loc. That's just like a quick slide. Again, this means I want all the columns, right? I can just do this like quick thing with loc. This is the exact same result as this. except this just looks nicer and better. But this one I can also like remove columns if I want, I guess. So it's like you have an extra feature. Splitting part, right, part 2. So this all comes back to remember when I told you a column was just a series. Okay, so when using Boolean arrays to filter, it is very efficient because using logical operators on series generate Boolean arrays. Now, this is like kind of initially crazy, right? Like this kind of makes no sense in Python, right? How can you compare a list to this number 610, right? But I've got my top 10 table, right? These are top 10 states with top 10 what happened to the okay, whatever, top 10 some score, right? I've got the top 10 states, and I want the math column. And if I compare this to a number 610, this will just return if that at that given index, if that value is above 610, it will become true, else it'll become false. Right? So if we look at this example here, the 0th row, where's the math column, right? It's here. Is 620 greater than 610? It is. Great. True. Is 616 greater than 610? True. Right? You kind of get the point. If I go to next to South Dakota, I go to the math column, right? Because that's what I've selected. Is 609 greater than or equal to 610? No, it is not, right? So I put this false. Now, why is this so useful for filtering, you might ask, right? Very naturally, if I have my top 10 states, I can just put this line of code right here, which is a Boolean array, right? A Boolean series, Boolean array is basic, by the way, the same thing in this context. I can just shove this in to the brackets, right? Because remember I told you this can take in a Boolean array, right? So I can just take this, and shove it into that bracket, right? So it looks like this. So top 10, I got my table. Then I want this Boolean array where the math score is greater than or equal to 610. So now what's going on is that I've created this Boolean array of trues and falses right here. Then those trues and falses go into this, and I select base out which ones are true and which ones are false, right? So in this case, it'll only be true if the math is above 610. So if we look at this table, I've extracted these out. You'll notice this math column, everything is above 610, right? So what I've essentially done is filtered out all rows where the math score was under 610, right? So South Dakota with 609 is thrown out, right? Wisconsin is thrown out. Missouri, Wyoming, Kansas are all thrown out, right? What's left are the math ones that are above 610. Now, immediately, I hope, right? There's like a lot of possibilities you can immediately think of, right? That you can do with like this idea, right? Of a Boolean array. All we need is a logical operator, and that's it. One quick note is that and or still exist. They're just the ampersand and this bar, which means or, right? So if I want to, for example, filter at two things at once, I can just do that, right? So this is a Boolean array, and this is a Boolean array. So if I, for example, want the states where both my math is above 610 and my writing score is above 579, then I can just do that, right? So North Dakota, is the math above 610? Yes. Is the writing above 579? Yes. Okay, so both of them are true. True and true returns true, right? In this case as well, true and true returns true. What about in Iowa's case? Math is above 610, true. However, writing is not above 579. right? It becomes true and false, and therefore that returns false. If you're not familiar with Python, and returns true if both are true, and or returns true if at least one out of two are true. And then if you go down this list, you'll realize that this satisfies both of these conditions, right? And so again, I can just shove this giant Boolean array I just created into this top 10, like into this bracket shorthand, right? And I can just filter out basically everything that I can just filter in, keep every state where both the math and the writing is above, well, math is above 610 and writing is above 579, right? So if I run this command on this table, then all that's left is North Dakota, Illinois, and Michigan, in which case, right, the math, the writing are both above these two respective values. So I'm kind of out of time, so I'll quickly go over the demo. So first I do this iloc, right? So this is just basically taking the first 4 rows and then the first 4 columns or 5 columns, right? This is just so we can work with a smaller data set. So if I do put in my array true, false, right? That means I want this index. I do not want this index. I want this index. I do not want this index. What's output it is exactly that, right? I have North Dakota and Iowa. Now, I set top 10 to the top 10 rows in SAT. Means the top 10 states with the highest combined SAT score. Right. So now, if I just put a lengthy array of length 10, right? I'm saying I want North Dakota. I do not want Illinois. I want Iowa. Da 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 da. I want every 2, and what I'll get is every 2. Right. Again, so if I have a logical operator, which is just like greater than or equal to, there's also double equals, right? Less than or greater to. I forgot. There's like a bunch of different other things that you can use. I can go over them if you want, but just like these ones are like sort of the most important ones intuitively, right? There you can like, for example, a string you have like dot contains, right? If that value contains this string, then return true or false, right? So if I want like all the states where I don't know, that start with W, I can just do that, right? And this like Boolean array idea is very powerful. Right? So in this case, I compare the math with 610 and the top 10, right? And I return again a Boolean array of trues and falses. I can stick this into top 10, my bracket, right? This like notation, the shorthand notation, like da da da. I can stick that in, just filter it. So now I've got one of the math scores was over 610. Again, and works as intended. Right? So I want both of them. And I can create this long, but it's just one Boolean array. Notice that because this column came from the table, the number of rows is the same, right? The length and number of rows is the same. Now I can shove this long expression into the bracket notation and filter by this. What's left are just the 3 states where both math and writing are above these 2 respective values. And you can also do this with OR, which obviously is less restrictive, so you get more entries. So I believe that's actually it for today. So a quick summary, main takeaways, is that this notation, this bracket, get used to it. Because this is way more in practice used because computer scientists are very lazy and don't really like to type loc and iloc and set up whatever. Although it is true that loc has more power when it comes to extracting, you can extract more specifically, right? But this shorthand is normally too convenient, so you should probably get used to it, right? And the tricky thing about this notation is that it can take in 3, 4 different things, actually, from what we've seen, and do 4 completely different things, right? You can put in a slice to get row numbers. You can put in a list of column names to get a table. You can put one column name to get a series, right? And then you can also put a Boolean array to extract or to filter, right? Again, the condition extraction. The core idea is that if you put a Boolean array, it will pretty much match index to index which one it wants to keep. And when you compare a series to a logical operator, then what is output is your filter table, right, in this case. And then next week, we'll be learning how to add, delete, and edit columns. Adding is very important. Deleting is less important because normally people just select like everything they want first. So for example, if I want to delete the in this case, for example, if I want to delete the critical reading column for some reason, I can just select these other 5 columns, and I've essentially deleted it. But adding columns is very important, which I'll talk about. And then editing columns. This is obviously pretty useful, right? And then I'll talk about important functions next time, right? I gave like a little sneak peek last week, like so value counts, for example, sort values is in here. Dot unique is in here. Like dot str like contains is also in here. And then group by. And you've heard me talk about this quite a bit. You've probably even heard Professor Xiaojing talk about this quite a bit, because this is literally, if not the most important idea or function of tables, of data frames, right? And then I'll talk about joins and mergers next time if we have time, but this also turns out to be quite complicated because there's like 4 different joins that you can do, like types of like joining tables that you can do, but intuitively this is just like putting 2 tables together. Yes, and that's actually it for this week. And then I will, like always, push the demo into the GitHub branch if you guys want to see it. And yeah, you can stop the recording now, and then